Hello everyone, welcome to the class once again. I hope you're all doing good and you're the best of your health. So you must be remembering that we have learned all the concepts in this chapter of mechanical properties of fluids. We have learned about Bernoulli's theorem, we have learned about equation of continuity, we have learned about surface tension and all the concepts based upon this chapter. In this chapter, in this exercise, you'll be practicing JEE Main pattern questions. The questions will be of single choice question, that is one option will be the correct answer and rest will be incorrect. So in your examination, you have to choose one option which will be the correct answer. You should know that the JEE Main examination, the questions asked are not too easy, not too tough. The level of difficulty is quite moderate and the examiner tries to check your in-depth understanding of the concepts. So let's go ahead with the kind of question that would be asked in your JEE Main examination. Let's start with the first question of the day. Water from a tap emerges vertically downwards with an initial speed of 1 meter per second. The cross-sectional area of tap is 10 to the power minus 4 square meter. Assume that the pressure is constant throughout the stream of water and that the flow is steady. Let me tell you that this is stream of water, need not to get confused, and that the flow is steady. Cross-sectional area of stream is 0.15 meter below the tap is. Cross-sectional area of stream 0.15 meter below the tap is A 5 into 10 to the power minus 4 square meter, B 1 into 10 to the power minus 4 square meter, C 5 into 10 to the power minus 5 square meter and D 2 into 10 to the power minus 5 square meter. So I believe that you have understood what the question is asking from us. There's a tap, water is coming out from the tap. We need to find out stream of water, cross-sectional area of stream 0.15 meter below the tap is. That is, if you see the tap and if you see the running water that is coming out from the tap, this is the case. Let's say this water, let's say this is a tap, as you can see that, and if I show you the exact cross-section a bit in an elaborated way, let's say this is the tap. Don't think that I have drawn a very wide mouth of the tap. Water would be coming out from this, and let's say this is the case, water is coming out, and if you have noticed, the water stream tapers at the bottom. It will be narrower at the bottom. So let's say this area of cross section at the bottom is different, and let's say it's A2. The area of cross section at the top, it's A1. So this is the water that is coming out through the tap. Try to understand that I have drawn a stream of water that is coming out from the tap. Now it says that if you read the question statement, water from a tap emerges vertically downwards with an initial speed of 1 meter per second. That is, the speed at this point is 1 meter per second. So let me write this as V1 is equal to 1 meter per second. I hope that this would be clear to you all. The cross-sectional area of tap is 10 to the power minus 4 square meter. That is A1 that we have made here. This is 10 to the power minus 4 square meter. Next thing, try to see here. Assume that the pressure is constant throughout the stream of water and that the flow is steady. Cross-sectional area of stream 0.15 meter below the tap is. So we need to find out what is the cross-sectional area at this point. So by any means, let's say if we take the speed of stream to be V2 here, then what we can do? It says that pressure at every point is equal, and that can be taken as to be equal to atmospheric pressure. First of all, you see whatever water droplets coming from this end, if I draw in this way, it's starting with a speed of V1, that is 1 meter per second, and it will travel a height of, that is 0.15 meter. This is the height 0.15 meter. So can we comment on this using the concept of V equals to U plus 2AS? From there, what we can get, we will be getting the value of V2. If we using V equals to U plus, V square is equal to U square plus 2AS, this is what we can use. V square is equal to U square plus 2AS. So in this case, final velocity will be V2. Let's write here V2 whole square is equal to V1 whole square plus twice of GH. So we can evaluate the value of V2. So one formula will let us the value of V2 And after this, what we can do? We can use the equation of continuity. We can equate A1 V1 equals to A2 V2. So see here, V2 whole square. So V2 whole square is equal to V1. V1 is 1 whole square plus twice of G, that can be taken as 10, and H is given as 0.15 meter. I believe that this should be clear to you all. See that it's given that 0.15 meter below the tap. So V2 you will get as in this way as it's shown here. So this will come out to be 1 plus 1.5 into 10. So this will come out to, you see here, 2 into 10, 20, or you can just take here 1.5 into 2, 3. So this will come out to be 4. V2 whole square is 4. So V2 will come out to be 2 meter per second. This is the value of the stream of water at this lowest point. After this, we need to evaluate the value of area of cross section at this bottom end. Can we use equation of continuity? I hope that you would have taken note of this, and let me rub this part. Let me rub this part and let us go ahead using equation of continuity. Equation of continuity, if we use, we will be obtaining, or we can write A1 V1 is equal to A2 V2. From here, we need to find the value of A2. A2 will come out to be, A2 is equal to A1 to V1 by V2. Equate it. A1 already we know that's provided to us, and A1 is 10 to power minus 4 square meter. 10 to power minus 4 square meter. Let's put the unit at the end point. V1 by V2. V1 is 1, V2 is 2. So 1 by 2. This is what we are going to obtain. So this will be equal to 1 by 2 is 0.5. So 0.5 into 10 to the power minus 4, or we can write 5 into 10 to the power minus 5 square meter. 5 into 10 to the power minus 5 square meter. This is what we are going to obtain in this case. This is the value of area. 5 into 10 to the power minus 5, let's check. A option, 5 into 10 to the power minus 4, incorrect. B, 5 into 10 to the power minus 5 square meter, yes. Sorry, it's C option. It's C, 5 into 10 to the power minus 5. B, 1 into 10 to the power minus 4, incorrect. And D, 2 into 10 to the power minus 5, incorrect. I hope that you have got how to do this such kind of question. First of all, you need to understand what formula you can apply. You need to differentiate yourself in your mind that whether you require Bernoulli's theorem or you can use only equation of continuity. You should go ahead and should think that if you want to use equation of continuity, you should know the speed at this point. And that you can only obtain when you have applied the equation of motion and you know the velocity at this point. So that thing will give us the value of velocity, or you can even conserve energy, whatever you wish, you can apply as I have told you in this subsequent solution. So this was a good question. It has been asked in your previous year mains examination. So I believe that you would be getting to know what kind of questions can come in your examination. Let's go ahead with the next question. Second, a closed compartment containing gas is moving with some acceleration in horizontal direction. Neglect effect of gravity. Then the pressure in the compartment is A, same everywhere, B, lower in front side, C, lower in rear side, and D, lower in upper side. Let's go ahead and let's check the scenario what is happening. It says that it's a container, there is a gas contained in it. A closed compartment containing gas is moving with some acceleration. So let me show you the scenario. Closed compartment. We have this as a closed compartment. It's moving with some acceleration. There's a gas which is contained in it. So let me show you, this is the gas that is contained in it. Now it's required to know that how to differentiate pressure at various positions in this container. Whether the pressure is same everywhere, whether it's lower in the rear side or lower in the front side or lower in the upper side. So we need to find out, is the pressure same everywhere or it's different at any other point. Now to do such kind of question, what we can do, we can actually, what you do, take any part. I have taken a small part, let's say the area of cross section of this part is A, its length is given as L. Let's say this is the case. So there will be gases that would be contained here. Now if I talk about its motion, because this entire gaseous system which is contained within this portion, it is moving with some acceleration, that is what is given. So if I take pressure at this point as P1 and pressure at this point as P2, can we write net force is equal to mass into acceleration? If the mass of gas contained here is m, so we can write that P1 minus P2 into A, pressure into area, pressure difference into area will give you the net force, is equal to mass into acceleration m into A. Quite simple. Now here only we can actually comment on the value of difference in pressure, how we can evaluate. Now see, this entire term is positive, m into A is positive, that means P1 minus P2 has to be positive. If P1 minus P2 is positive, that means P1 is greater than P2. So if I write here, P1 will be greater than P2. That means the pressure at the rear end is more compared to the pressure at the front end. That means pressure will be lower at the front end. So if you see A same everywhere, no. B lower in the front side, yes. The pressure is lower in the front side. C lower in the rear side, no. It's higher in the rear side. D lower in upper side, no. It's lower only in the front side. I hope that this has made you understand how to understand such kind of situations. And in our regular classes also we have discussed such cases in derivation portion, and I believe that you all can easily think on your own also how we have approached this problem. Let's go to the next problem of the day, question number 3. There is a circular tube. You can see a circular tube in a vertical plane. Two liquids which do not mix and of densities d1 and d2 are filled in the tube. Each liquid subtends 90-degree angle at center. Radius joining their interface makes an angle alpha with the vertical. You can see that radius joining their interface makes an alpha with the vertical. Ratio d1 by d2 is, that is, you have to compare the densities, is 1 plus sine alpha upon 1 minus sine alpha, B 1 plus cos alpha upon 1 minus cos alpha, C 1 plus tan alpha upon 1 minus tan alpha, and D 1 plus sine alpha upon 1 minus cos alpha. There is a circular tube in a vertical plane. Two liquids do not mix and of densities d1 and d2 are filled in the tube. Each liquid substance 90 degree. Now let's go ahead and let's do it here. Let me show you the entire scenario. This is the tube and I am drawing a larger cross section for your better and clear understanding. This will entail in better understanding of the thing that will be discussed. This tube has a width so that liquid can be taken to be contained in this. Now you see here it's given that both make an angle of 90 degree at the center. What does that imply? That means the circular arc of which it will be contained, where it will be contained, that will be same in both the cases, and that will be quarter of a circle. That means, now you see here it's given that if I show you, if I join these points, and now you see here one liquid is contained here and the other one is contained in this portion. This is what that has been shown. So if I am showing you here, this is the one liquid and the other liquid is contained here. So I am drawing the other liquid with different color. Hope that this thing is clear to you all. Now it's given that alpha is the angle. You can see that this is the angle alpha. So if I draw angle alpha separately, so this will be angle alpha. We need to comment on the ratio d1 by d2, and before that it's given that its radius is r. Let me show you something more based upon all these things. One more thing, this length, if you see this length and this length, if we compare, Although it shows that both are unequal, but both are equal as per the given scenario in the question part. So if I draw this line, understand, this is alpha, this is 90 degree, this will be 90 degree, automatically this will be also alpha. I hope that this will be clear to you all why this is alpha. Next, you can comment on this angle, this will be 90 minus alpha. So I believe that the entire figure which I have drawn, that would be clear to you all. Let me mark some more things in this diagram. So what to do before that, first you take note of this. I will draw some more specification in this diagram, don't worry about it. So now in this picture it will be clear to you how to go ahead. Now see here, if I talk about this bottommost point, let's say the bottommost point is point O, and let's say the density that is given, this is of density D1 and this is of density D2 in the two cross sections that is provided. Now see here, pressure due to this part will be equal to pressure at this part, then only the system is said to be in equilibrium. So if I equate the pressure at O due to right hand part and due to left hand part, what equation will be reaching at? So equating pressure at O due to both arms of the tube, equating pressure at O. See here, first of all, try to understand the pressure at this part due to this right column. See here, it will be due to this part of the liquid and due to this part of the other liquid. The pressure due to the left column will be only due to this part. We know that pressure is only dependent upon height, and that is equal to H rho G. Now the height, if I talk about this entire height, see this height will be how much? This height will be equal to R sin alpha. So let me write here each of the height separately. This will be R sin alpha. And now you see, if I talk about this is R, this is 90 minus alpha, quite clear to us. So this height, let me just rub some portions. See here, from here, this height if we talk about, this will be equal to R sin 90 minus alpha, that will be equal to R cos alpha. Let us write here R cos alpha. Next thing, now talk about this height. Let's talk about this height. See here, this is R cos alpha, this is entire R, so this height will be R minus R cos alpha. This will come out to be R 1 minus cos alpha. So we got this. Now let's go and equate for the pressure, and before that the height, if we are concerned about this height also. Now let me mark here this height. This height will come out to be till point O. If we go ahead, this height, now see this is R, this is also R, this is entirely R, this height will be R cos 90 minus alpha, that is R sin alpha. It will come out to be R 1 minus sin alpha. Hope that how we have reached to this height, that would be clear to you all. R 1 minus sin alpha. This thing should be clear to you, because this height will be R cos 90 minus alpha, that will be R sin alpha. So R sin alpha, you remove from R sin alpha, so you will get R 1 minus sin alpha as this height. Let's go ahead and let's equate the pressure for it. Pressure due to right end, R sin alpha D2 plus R cos alpha D2 plus R 1 minus cos alpha D2. So you will be having R sin alpha multiplied with D2. See, I am not multiplying G. G will be cancelled out overall, so I am not multiplying G. And R cos alpha plus R cos alpha multiplied with D2, then plus R 1 minus cos alpha, R 1 minus cos alpha multiply here D1, because the liquid in this part is other one, that is of density D1. Now for here it's equal to R 1 minus sin alpha D1 is equal to R 1 minus sin alpha D1. I believe that you can clearly see up till that, and from here onwards, let's go ahead. R sin alpha D2 plus R cos alpha D2, and here you have D1 and D1. So if I am going to take D2 as common and R will be cancelled out, so we will be having D2 sin alpha plus cos alpha is equal to R is cancelled out. Now D1, 1 minus cos alpha, if it goes here, you see 1 and 1 will be cancelled out. You will get cos alpha minus sin alpha. Cos alpha minus sin alpha. We require the ratio of d1 by d2. So implies that d1 by d2 will be equal to sin alpha plus cos alpha upon cos alpha minus sin alpha. This is the ratio that we are getting for d1 by d2. Let's check with the option sin alpha plus cos alpha upon cos alpha minus sin alpha. There is no such option that we can see, but we have an option for tan alpha. Rest everywhere we are having sin alpha and cos alpha form. So if we divide numerator and denominator by cos alpha, we will be obtaining, let me rub some part. If I rub this upper part to show you all the leftover part, so d1 by d2 dividing numerator and denominator by cos alpha, we will be getting 1 plus tan alpha upon 1 minus tan alpha. This is what we are getting. Let's check with the option. 1 plus tan alpha upon 1 minus tan alpha, option number C. Rest all will be incorrect. It's a very good question. It has been asked in your previous examination. You should know how to approach such kind of question. You know, if you practice, you will reach to the answer. The only problem in this question comes to save time. You will take time on this. If you know the basics, if you have practiced more, it will be very easy for you all to conveniently proceed and get to the required result. Hope that it's understood by everyone who are watching me. And now I'm rubbing this, and I hope that the question is clear to you all. This chapter, many good questions can be framed in this chapter. And let me tell you, concepts from other chapters also can be used to frame question in this chapter. Let's go ahead with the next question. Fourth one. A vessel contains oil, density 0.8 gram per cubic centimeter, over mercury, density 13.6 gram per cubic centimeter. A homogeneous sphere floats with half its volume immersed in mercury and the other half in oil. The density of the material of the sphere in gram per cubic centimeter is A 3.33, B 6.4, it's A 3.3, B 6.4, C 7.2 and D 12.8. Let me show you the scenario what's happening. We have two immiscible liquids which are contained in a container. So I am showing you two liquids, one is mercury, one is oil. So mercury will be, normally it will be in the bottom part, its density is quite high. So this is mercury and density of mercury is given as 13.6 with proper SI units, gram per cubic centimeter. Then in the above part you have oil whose density is different. Let's see the density of oil that has been provided to us, that is 0.8 gram per cubic centimeter, 0.8. So I am going to use here density of oil that is equal to 0.8 gram per cubic centimeter. Now this is a homogeneous sphere which floats at the center part. You see a homogeneous sphere floats with half its volume immersed in mercury and the other half in oil. So if I draw a sphere which is floating, take in this way, this is the sphere. Half its parts, so half of its volume will be in oil, half of its volume will be in mercury. Let's say its total volume is V. We all can say that the net upthrust will be equal to the net bottom weight that will be acting on the body. Its weight will be equal to volume into density into gravity. So volume into density of the substance, let's take it as rho into gravity. Volume and density will give you mass, into gravity that will give you the weight. So weight will be equal to net upthrust. Weight will be equal to net upthrust. From here, weight is volume into density into gravity is equal to upthrust due to mercury V by 2, density of mercury into G plus V by 2, density of oil into G. Clearly you can cancel out this G term, you can cancel out this V, and you will be getting the density of the substance will be equal to half of density of mercury plus half of density of oil. Substitute the values, you will be obtaining 13.6 divided by 2 plus 0.8 divided by 2. 13.6 divided by 2, that will give you 6.8. That's quite clear. 2 into 6, 12, 1 is 16, that will give you 0.8. 6.8 plus 0.4, that will give you 7.2 gram per cubic centimeter. Clear to us, 7.2 gram per cubic centimeter is the density of the substance. So A is 3.3 incorrect, B is 6.4 incorrect, C 7.2 in gram per cubic centimeter, yes, that's the correct answer. D 12.8, that's incorrect. Hope that's clear to you all how to solve such kind of question. Remember, the upthrust will be due to both the liquids, not only due to mercury, it will be also due to oil in this case. And I know that you will be knowing that why we are discussing, why I am saying that the upthrust will be both the liquids, not only due to mercury. You must be some of you must be thinking that oil is not penetrating beneath the object, so you may be thinking that upthrust may not be applied due to it, but no, upthrust will be applied as the object is not touching the bottom of the beaker, it's somewhere floating, so you have to use the upthrust due to both the liquids. Let's go ahead with the next question of the class. Fifth one. Water is filled in a cylindrical container to a height of 3 meter. You can see that water is filled here. The ratio of the cross-sectional area of the orifice and the beaker is 0.1. You can see here this is orifice and the beaker is 0.1. The square of the speed of the liquid coming out from the orifice is G equals, take G equals to 10 meter per square second is 50 meter square per second square, 50.5 meter per square per second square, 51 meter square per second square, and 52 meter square per second square. Such kind of liquid which ejects out from a container, we have solved such questions and we have learned its theory how to approach. You have a container and you have an orifice through which water is coming out. This height is given as 52.5 centimeter and the entire height is given as 3 meter, that is 300 centimeter. The entire part is containing water. The area ratio is also provided to us. Now see here the area ratio that is provided to us, if this area is A1, this area is A2, so it's given that A1 by A2 is equal to 0.1. This is that has been provided to us. Now, can you imagine what formula you can use? Easily we can use the concept of the Bernoulli's equation. We can say that if the atmospheric pressure is here P naught, it will be P naught at this end also. So equating pressure or using Bernoulli's theorem at the 2 points, using Bernoulli's theorem, let us say if this is h we have taken and let us say that this height is h dash from this portion orifice to this top height, it's h dash, that is what we have mentioned here. Using Bernoulli's theorem we can write P naught plus rho g h dash. We have taken this as the part, this as the level from where we are going to measure the height. So P naught plus rho g h dash plus half rho, and let's take the velocity at this point is v2. Let's take the velocity, this will equate to 0 also, don't worry. We are taking initially v2, half rho v2 whole square is equal to P naught, h will not be taken here, plus half rho v1 square. v1 is the speed with which this efflux is coming out. Conveniently you can say that this P naught and P naught will be cancelled out. So you will be getting rho g h dash plus half, and rho will be also cancelled out, so need not to worry about it. So you can write that g h dash plus half V2 whole square is equal to half rho V1 whole square. This is what we can do. So what you do, take note till here, and let me start at the other end. Take note till here. So I believe that you have taken note of this. Now one more thing, I have removed rho from here, and this row should be also removed. Next thing, let me rub this part. I believe that you have taken note of this diagram. Let me rub this part, and this is not required anymore. So I am rubbing this part. I believe that all the numerical values of the things you must be remembering. Next thing you see, if we simplify this, we can write 2g h dash is equal to v1 square minus v2 whole square. This is what we can do. v2 is at the velocity at the topmost point. From here you see here, we also know that a1 v1 is equal to a2 v2. So finally v2 can be written as v2 will be equal to a1 by a2 multiply with v1. So what you do, substitute this value of v2 in this equation. Let me write this equation number 2. This is equation number 1. Substitute the value of v2 from equation number 2 in equation number 1. 2g h dash is equal to v1 square minus, sorry, it's here v1 square minus v2 square, so a1 by a2 whole square into v1 whole square. From here v1 will turn out to be, v1 whole square will come out to be 2g h dash 1 minus a1 by a2 whole square. I believe that's clear to everyone. Now 2g h dash, 2 into 10, h dash is 300. If you take in centimeters, we convert it in meters. So 3 meters minus 0.525, you will be getting 2.475 divided by 1 minus a1 by a2 whole square, that is 0.1 whole square. So you will be getting this as 0.1 whole square. This is the term that you are going to get. This will be actually equal to 0.1 whole square will give you 0.01, then 1 minus 0.01 will give you 0.99, and if you proceed with the calculation portion, you will get this as 50 meter square per second square. This is different. So 50 meter per square, 50 meter square per second square, this is the required result in this case. Because you have to find out the square of the speed. You see here, the square of the speed of the liquid coming out from the orifice is A 50 meter per square, 50 meter square per second square, yes. Rest all options are incorrect. The options are very close to each other, so calculation is required. So you must be knowing that in your JEE examination, some questions can be raised which also requires calculation. So these were the first 5 questions in this exercise that we have discussed. The next 5 we will be discussing in the next section. So till the time, thank you everyone and wish you all the very best. Hope this class would be of great help to you all.